Hello. In this video, we're going to continue to talk about doing antiderivatives. And so I want to find this integral of 2x times the square root of 5 plus x squared dx. Now, using our traditional methods, we wouldn't be able to do this antiderivative. So we're going to introduce something new, and that something new in regards to antiderivatives is substitution. So what I'm going to do is I'm going to let u, so I'm going to introduce the variable u, and I'm going to let it equal 5 plus x squared. 5 plus x squared is the function inside the function of a square root. If I do the derivative of u, so I do du, then I'm going to get, well, the derivative of 5 is nothing, the derivative of x squared is 2x, and then times dx. That was the integration by parts that we did many months ago. Using this new information, I can go back to the original derivative and replace that information with our new information. So we're going to have the antiderivative, or the integral of, well, the square root of 5 plus x squared. Well, u is the same as 5 plus x squared, so I'll have the square root of u. Du is the same thing as 2x times dx, and that's what we have here, 2x and dx, so times du. Now we know how to integrate this. I know that the integral of the square root of u will be 2/3 times u to the 3/2. Right, if I took 3/2 times 2/3, it would become 1, decrease my exponent by 1 back to 1/2, and then the plus c at the back end. But I didn't start with u, so let me go back and replace that. So instead of u, it was 5 plus x squared, so we have 2/3 times 5 plus x squared to the 3/2 plus c. Or I can write it as 2/3 times the square root of 5 plus x squared cubed plus c. So either way, we want to write it as fine, but this is the antiderivative of that 2x times 5 plus x squared dx. So let's talk more about the substitution rule. At the top of this page here, I have some information on the substitution rule, and we have some variable u that equals a function g of x. And what we're going to do is try to, when we're doing integration, look inside some function x and see if there is another function inside of it. So basically we're using substitution to undo the chain rule. So when I did the chain rule, I would do the function on the outside and derive that first, then take that times the derivative of the inside. So if g of x is the inside function, and then I do the derivative of g, I would get g prime of x. And so what this allows me to do, if u equals g of x, that would mean that u prime is the same as g prime of x times dx. And so I can go through, and instead of g prime of x dx, I can replace those with the du, which is right there. So in example 1, I have the integral of x squared times secant squared of x cubed plus 10 dx. Now, my function within a function, inside the secant squared is x cubed plus 10. So I'm going to let u equal that function inside the function. I'm going to let u equal the x cubed plus 10. Now, if I do the derivative of that, that's 3x squared, and then the plus 10 becomes 0 times dx. So looking over there, I can see that I have that x cubed plus 10 right there, but outside that function, it's an x squared and not a 3x squared. So what I can do is, instead of leaving that I can get rid of the 3, and I'm going to divide both sides of this equation by 3. So 1/3 of du is the same as x squared dx. So going through my integration, instead of secant squared of x cubed plus 10, we'll do secant squared of u. And then instead of x squared dx, that's the same as 1/3 du. So when I integrate, that 1/3 is capable of just sliding out front. So secant squared of u du. And now we do the integration. The integral of secant squared is tangent, so we end up with 1/3 of tangent of u, still plus c, and now we input our original information for u. So 1/3 tangent x cubed plus 10 plus c, and there is the antiderivative. We can always test this by doing the derivative of that. So if I did the derivative of my circled piece, well, it's going to be 1/3 times, we do the derivative of the outside, derivative of tangent is secant squared, still inside, times the derivative of the inside, which is 3x squared, times the dx. And when we take 1/3 times 3, they would cancel, and so we would get x squared times secant squared of x cubed plus 10 dx, and that is indeed my original function. So that's it for the substitution rule. We are done.